1897. So there were two famous scientists. Uh, in fact, there were actually three scientists who have worked on. So the setup that you are seeing here, so the setup that you are seeing actually here in the anode ray, this discharge tube setup, and in the cathode ray, this discharge tube setup was together studied. So the concept of discharge tube, there is this scientist named as William who have introduced the concept of discharge tube. And this led to the discovery of anode ray, cathode ray, which further contributed a lot in the discovery of subatomic particles. So when let's first do one thing, let's start with the negative one, because uh, we want to be positive for the best part of the time. So negative, let's quickly complete this and let's get positive. So anyway, I'm bad at jokes, by the way. So coming back to this cathode ray tube experiment, it was conducted by Sir J.J. Thomson. He is a Nobel Prize winner, and the great fact about Sir J.J. Thomson is he's a Nobel Prize winner. His son is a Nobel Prize winner. His students are Nobel Prize winners, and his student is also a Nobel Prize winner. So coming to Sir J.J. Thomson, he have set up this cathode ray tube experiment where he have pointed out cathode rays. So what exactly is this cathode ray tube experiment, and what should we study about this cathode ray tube experiment? Let's start it stepwise. Let's first decode his experimental setup. So now, to decode his experimental setup, he have chosen a glass tube that is around 50 to 60 centimeters long, a discharge tube that is around 50 to 60 centimeters long, and with the help of vacuum pump he have created low pressure and some gaseous residue in the discharge tube. Now when there is low pressure and gaseous residue, he have used high voltage generator and discharged around 10,000 volts of electric current inside this discharge tube, that led to movement of this cathode rays inside the tube. Now what exactly happened is something that you might be wondering. So when he have set up, so when he give me a second guys, let me clean up the board so that you can see clearly. Okay, with the help of vacuum tube he have created low pressure, and there was already gaseous residue for timing. Let's consider it to be H2. So in this scenario what happened was, upon releasing 10,000 volts or 10 kilovolts, which is nothing but 10,000 volts of electricity, the cathode side, which is also called as the negative terminal, released a set of rays towards positive side, and these rays are invisible to the naked eyes. There were two main reasons how he spotted those cathode rays. So in this experiment, the primary question arises is how Thomson spot cathode rays. That is a very critical question of this experiment, because for the time being there are two major reasons, and logically those two reasons are being right. So some book says that when cathode ray experiment was happening, the gaseous molecule inside the discharge tube got clashed with the cathode rays, and the release of energy came out in form of light, and it gave a visibility. The cathode ray path was visible to Thomson. So that was the first assumption that was taken. The second assumption that was taken was perforation at the anode end. So let's write down the first assumption. So first assumption was cathode rays collided with the with what exactly they did collide. Cathode rays collide with gas residue in discharge tube and release of energy due to collision was in form of light. So that was the first reason. Now coming to second reason that I was mentioning about the perforations in the anode. So this is the anode end, right? So this anode end had multiple perforations. That means the anode end was they made multiple holes in the anode end, and when cathode rays move towards anode, they pass through these perforations and they'll somehow end up hitting the screen behind it. So when the screen behind it gets hit with when the screen behind the anode are being hit with the cathode rays, there is emission of light, and shows that cathode rays have been moving. There is something that have been moving in straight line towards anode, and since it is from the cathode, J.J. Thomson named it as cathode rays. So let us then write down our second reason. So reason number 2, perforations in anode led to visibility. uh, Perforations in anode let the cathode rays hit the fluorescent tube behind it, generating glow and spotting cathode ray path. So these were the two major assumptions in cathode ray experiment, and by the time this experiment was successfully ended, J.J. Thomson have come up with two major conclusions. So J.J. Thomson's point of view was there was some rays which are emitted from cathode end towards anode end, so those rays are called as cathode rays. And these rays are made up of some particles, and he named those particles as negatrons. Now, the fun fact is these negatrons were in future renamed by Stoney as electrons. So J.J. Thomson was the person who have discovered electrons in form of cathode rays, but he named those cathode ray particles as negatrons. Later, there was this another scientist named as Stoney who have renamed negatrons as electrons. So similar setup was followed, and this experiment was carried out. The anode ray experiment followed the similar setup. The only difference is there was perforations at the cathode end instead of anode. So perforations were at cathode instead of anode. Very importantly, more importantly, in this whole experiment, the anode rays were called Canal rays, and this experiment was done by Goldstein. So Goldstein was the person who have identified positive particles and who have brought down the concept of positive rays, canal rays or anode rays. Now moving to the Next discovery of neutrons. But before that, few of you might be wondering what exactly have happened. So Thomson was the one to find out negative rays or negative particles, which he named them as negatrons. So those negative rays are cathode rays. Cathode rays are made up of negatrons. That was the, what do you call, that was the conclusion of Thomson. But there was this person named as Tony who have come up saying that okay, these negatrons shall be renamed as electrons, and finally Thomson have still have the credit of discovering electrons and Stoney have the credit of renaming it. Then moving to another experiment, Goldstein was the person who have discovered positive particles or positive rays, naming them as Canal rays, but proton was formally identified by some other scientist, which we would be studying in the upcoming slides. For now, let's understand the discovery of neutrons. As you can see, it was 1886 for discovery of anode, 1897 for discovering of cathode. Then what it took, then why did it take so long that we had to wait till 1932 for discovery of neutrons? So neutrons are chargeless bodies. Coming to neutrons, these are chargeless bodies, and since these are chargeless bodies, they cannot be tracked easily. These chargeless bodies cannot be tracked easily, and hence it took a lot amount of time to discover them. So now, before getting into this actual concept of neutrons, let us understand the setup, experimental setup. By the way, who discovered neutrons? Yes, it is Chadwick who have discovered neutrons. As you can see it on the PowerPoint, it's not a rocket science to scratch your head that who discovered neutrons, right? So neutrons was discovered by Chadwick, and let us first break down his experimental setup. Chadwick have bombarded alpha particles, and people who are wondering about alpha particles, we have already studied in the chapter atoms and molecule that alpha particles are nothing but helium atoms which are positively charged. So since alpha particles are helium atoms which have +2 charge, the mass of alpha particle shall be same as helium particle, and the atomic number also shall be same. So alpha particles are nothing but helium atoms with +2 charge, and they have high similarity with helium atoms. Now, the fun fact is alpha particles are sourced out from radioactive decay. So alpha particles source is something that we shall remember is radioactive decay. And this radioactive decay can be seen in elements like polonium or radium. So when this person Chadwick bombarded alpha particles onto a thin sheet of beryllium, there was a reaction that have happened, and that reaction is termed as nuclear reaction. So alpha particles which have an atomic number of 2 and mass of 4, when bombarded with beryllium of mass 9 and atomic number 4, it got converted into an atom called as carbon with atomic number 6, mass 12, and there was a byproduct of neutron that got charge 0 and mass, like, mass 1. So here when we see this equation, we can feel that 4 have joined up with 9, 2 have joined up with 4. Now, this 4 plus 9 is equal to 13, and this 13 was segregated into C12 and neutron 1, and this 4 plus 2 together forms the atomic number 6, which is carbon. We might get that assumption. And since, okay, there is emission of one neutron, now neutrons are chargeless and they are highly invisible, they are definitely invisible. How can Chadwick detect that? That must be a question. So Chadwick have exactly right after beryllium sheet, he have inserted a paraffin wax. This is rich in hydrogen, and when neutrons are released, so when alpha particles were bombarded, neutrons were released, and right next to these beryllium sheets there were paraffin wax. So let's say Okay, so let's say these buds are beryllium sheets. This is your paraffin wax, and when alpha particles bombard this beryllium sheet, the neutrons immediately bombard this paraffin wax, knocking off some protons. So if there were no neutrons available, if there were no neutrons present, then proton shall not be detected, since it is a so we can understand this in a very simple way. Consider me standing here. There is a person in front of me, and in front of that person there is one more person. So unless and until I knock this person off, the opposite person shall not be knocked out. So Chadwick have inserted a detector, and this detector is ionizer. So, if there is nothing being bombarded, this detector won't capture protons. So, when paraffin wax was kept, neutrons got bombarded on paraffin wax, and since these are rich in hydrogen, the protons in the hydrogen were knocked out, and these knocked out proteins were detected in the detector. Now, since protons are being knocked off, then there must be something moving here, and these invisible things were concluded as the new subatomic particle, which don't have charge and are called as neutrons, and that came to the discovery of neutrons. I hope it was clear, it wasn't messy, and you would have understood it. So, for now, let's summarize it. Okay. So, coming to the summary of subatomic particles discovery, electrons discovered by J. Thomson, but renamed as electrons. Okay, so it was discovered by J. Thomson as negatrons and renamed as electrons from negatrons by Stoney. Now, so I hope you are clear with the discovery of electrons. Moving to the next important discovery, that is discovery of positive rays. It was Goldstein. He discovered positive particles and through the experiment of anode rays, this positive particle renamed, or more appropriate word would be formally identified. So we would be coming on to this in the next upcoming slides. But coming to our last subatomic particle, the last, very last but not the least subatomic particle, that is neutron. Chargeless body was discovered by Chadwick, and the most famous equation for this is alpha. Instead of alpha, you can say helium 4 2 plus beryllium 9 4 gave rise to carbon 12 6 plus 1 neutron. So this is one of the most famous equations of neutron's discovery.